Yes, is this audible, Reem? Only you have
Yes,
joined
ma'am.
the
Yeah,
student.
ma'am.
You all got the link no, today for today's class.
Yes, ma'am. I did.
Okay, so now you will be regular, Reem? From long
Yeah,
time
ma'am.
you had mentioned that you wanted to join. What had happened? You were not attending
No,
the
ma'am.
class?
I was in India for vacation.
Okay, okay. Now you've returned back to your
Yeah.
place. All right. Okay, so see, we had started with alternating current and maximum portion of alternating current we have completed. So, did you go through any videos, lectures, or do you have any idea about this, or should I share
Ma'am, I
the?
actually do. We completed this chapter this week.
You have completed this chapter
Yeah.
in school.
Yeah.
Okay, then let's continue. Then, wherever you're not able to understand, just let me know.
Okay,
All
ma'am. Okay,
right.
ma'am.
So see, for circuits having only a resistor, we have value of EMF as E naught sine omega t, value of current as I naught sine omega t. EMF and current both lie in the same phase for a circuit having only a resistor. So I naught is equal to E naught divided by R. This is for purely resistive circuit. Then you have inductor. Inductor present, a circuit containing only inductor. E is equal to E naught sine omega t, I is equal to I naught sine omega t minus pi by 2. Now, the current lags, or you can say voltage leads by 90 degree in case of a circuit having only an inductor. And here the current is equal to E naught divided by XL. The way we have resistor for this circuit, we have an inductive reactance for circuit having only an inductor. So it's E naught divided by XL. That is, XL can also be written as omega L, E naught divided by omega L. Then you have a circuit having only a capacitor. So E is equal to E naught sine omega t and I is equal to I naught sine omega t plus pi by 2. We have plus pi by 2 because here current leads and voltage lags by 90 degrees. So current is equal to E naught by XC and XC is written as 1 by omega C. So till here the basics we had covered. Till the other students are joining, uh, proceed with this question. Try this question, then I'll discuss it too. Pure inductor of inductance. This is 25 millihenry. This is connected to a source of 220 volts. You have to find the inductive reactance and RMS current in the circuit. And the frequency is given as 50 hertz. Note this down, question class, till the others are joining. Okay, see, it says that find the inductive reactance. Inductive reactance is XL. So XL can be written as omega L. Now omega is also not given. So we have studied omega can be written as 2 pi nu. 2 pi multiplied by linear frequency into the inductance. That gives XL. So from this you can calculate XL. Multiplied by pi. Pi is 3.14, frequency is 50, inductive reactance is 25 into 10 to the power minus 3. This much. So whatever you'll answer, you'll get this will become 100. 100 into 25 into 3.14, something like 3 point something, you will get the value of XL. From here, you can calculate the value of XL. And it has also asked us to calculate the value of IRMS. So IRMS will be simply ERMS divided by XL. ERMS is given to you as 220 volt. XL from here you can calculate, and that will be the value of IRMS from here. All right, note it down, one more numerical beat. Evan, these timings are convenient for you, no? On Tuesday and Thursday?
Yes, ma'am. That's why I changed.
Okay. See, the second question says that a coil has an inductance of 1 Henry. What will be the frequency? Will it have a reactance of 3142 ohms? And what should be the capacity of a capacitor which has the same reactance as that of the frequency? C class for the first part. L is given to you as 1 Henry. What will be the frequency? It will have the reactance. Okay. XL is given to you now. 3142 and nu is asked to you. Frequency is mentioned, angular of linear, nothing has been mentioned. It should be linear frequency only. Otherwise, you can, it should be specified. The question does not specify over here. So let's assume that this is linear frequency. Otherwise, it should be specified whether it's angular frequency or linear frequency. Otherwise, how will you calculate the answer? Anyway, so XL is written as 2 pi nu L. From here, frequency will be XL divided by 2 pi L. Frequency will be XL is 3142 divided by 2 into 3.14 into 1. So it will be 50, right? If you have 3.142, we write this. So this becomes, no, 500,000. This gets cancelled. Frequency will be approximately, it will be 500 hertz. Second part says what should be the capacity of a capacitor? Means C you have to calculate. C, the capacitance value. What should be capacity of a capacitor which has the same reactance as at that frequency? So this is the answer for the first part. See, XC will be equal to what? 1 by omega C. This C is unknown and this time XC's value is 3142 hertz. The value of, not hertz, sorry, ohms. This is a resistance. So hertz is the SI unit of frequency. So we'll be using ohms. This much and omega from 2 pi nu you can write. So XC will be equal to 1 by 2 pi nu C. Capacitance will be equal to 1 by 2 pi nu XC, which will be 1 by 2 into 3.14 into 500 into 3142. This much Faraday you will get as the capacitance. Fine. So I think most of you have not written the question as well. Note it down. Then we'll start with a fresh topic, LCR circuits. And that is very important from your examination point of view. But again, that will be only clear if you have revised this part that we had done in the last class. So all of your midterms are over, half-yearly exams, or are they still going on in your schools?
No, they just started.
They have just started. All right. In some schools, they have started in October and some have completed. And what about your pre-boards class? You have it in the month of December or Jan? When do you all have your pre-boards? Any idea? Yes, Emin?
November.
November?
Yes, ma'am.
Oh. So I think this is the earliest that I've heard. December and Jan. Okay, yeah. In India also we have it in December and Jan. All right. So Aman has it in November. So Aman, your school syllabus must be at the edge only now in your school.
No, ma'am. Actually, it's going along with our tuition portion.
Okay. This is going right now. Okay. Whenever you have your exams, no, just let me know if you have to take classes because in some other batches we are ahead. So just let me know.
Okay, ma'am.
And yes, class, as soon as you get a confirmation, at least about the month. I'm not asking about the schedule, just a month. Let me know. Like Madiha has December, Jan. So if you all have an idea, whenever you get, just let me know. Because we have to have the revision classes as well. See, now one major topic that is left apart from AC is your optics. Other chapters are very small. EM waves is small, atoms, nuclei, dual matter, semiconductors, all these are very small topics. optics is a major topic that is there. So after that, we have to have the revision classes also, because most of you have joined it in the middle of the session. Some of you are from the starting, like I think Reem, Rifat, all these are from the starting, but maximum of you have joined it from the middle also. So those students who have missed on the lessons, they can complete it from chapter 1 till wherever they have. And otherwise also we have to have revision classes. November and pre-boards in December. Okay. LCR circuits. See, this is very important. Please, whenever you do mark, this is important. This and the resonance part from this does come in your exams. Now, see, LCR means L, inductor is also there, C, capacitor is also there, and R, resistor is also there. Fine. We have done all these three circuits separately in the last class. That's why I was saying last class was very important, and this class as well. See, if what we had studied, current and voltage across a resistor both are in the same phase. Fine. And voltage across this will be equal to I multiplied by R, current into resistance if I is the resistance in this circuit. So revision also is done for the last class. VR will be equal to IR, both are in the same phase for a purely resistive circuit. For a purely inductive circuit, L is the inductance, VL, voltage leads the current by 90 degree. This has been depicted by this voltage across the inductor leads the current by 90 degree, and voltage will be equal to what? Current multiplied by the resistance. And what is the resistance that we get in case of an inductive circuit? XL. So I into XL. Then you have capacitance. In a purely capacitive circuit, we have voltage lagging by 90 degree. VC lags by 90 degree, or you can say simply current leads by 90 degree. Fine. So in these kinds of circuits, we have the voltage will be equal to current multiplied by the resistance of this, and resistance is X. All of you, I hope, agree till here. No doubt still here. This is just from the last class. If you have any queries, let me know. I'll repeat that part. All right, class? Fine. So E is equal to E naught sine omega t. This, now we'll combine all these three. Now, once you combine all these three, let's see with the help of phasor diagrams, what all things are possible. See, VL I have drawn here, VC I have drawn here, this is VR. Two conditions are possible in this. See, if your VL is greater than VC, VL is greater than VC. This can also happen, no? Your voltage across the inductor is greater than voltage across the capacitor. So VL is greater than VC. If two vectors are present, PL and VC, these are two phasors. If VL is greater, then when you will subtract this for the resultant will point towards the greater one. Agreed? So how will you get? For VL greater than VC, this will be VL minus VC. You will be having the net resultant phasor towards the inductor one, because this is greater than the capacitance, and this will be the resistor. Understood? And other case that is possible is VC greater than VL. If VC is greater than VL, that net resultant, if you have two vectors, 3 Newton and 2 Newton. So where do you have the net resultant? Towards 3 Newton, and magnitude will be 1 if they are separated by 180 degrees. Similarly here as well, VC is greater than VL. So resultant will be, this is VR and this becomes VC minus VL. So resultant you will be having VL minus VC. Here you will be having VC minus VL. These things you have to keep in mind, because two cases will be possible here. Because you're not sure about the magnitude, and you have to consider both the cases in the exam, in the question. Any case can be given to you. So VR is fixed because in case of VR you have it in the same phase, and everything is taken with respect to the VR. That is the resistor. So now you will be having two cases. You will be getting the value of the net resultant of the circuit as well, and everything in terms of both these two cases. Fine. Please, class, wherever you're not able to understand, stop me. It can happen that you're not able to understand, and any queries or any doubts are coming to your mind. You can also simply text me in the chat box as well, because these questions are very important. Okay. Yes, this is important. To solve this, we'll form an impedance triangle. See, what is Z? When you had the purely resistive circuit, only resistor was present. So resistance was R, current was I. Clear? When you had purely inductive circuit, that time the work of the resistor, or the work to oppose the charges, was done by XL. Similarly, as a resistor's work to provide the work of resistor in a purely capacitive circuit, you had XC that was also doing the same thing that a resistor does in case of a purely resistive circuit. If you have all these three together, resistor also, inductive reactance also, capacitive reactance also, then there has to be something that resists or the net resistance of the whole circuit. For LCR circuit, we use impedance. Now, calculation of impedance is a different thing, but what is impedance? It's simply the resistance or the opposition that is provided in case of a series LCR circuit. And why series LCR? I'm saying because all these three were connected in series. It could have happened that inductor and a resistor were connected in parallel and then the resultant was connected in series. But no, we have all these three connected in series now. So to get the value of impedance, now we draw a triangle, which we call as impedance triangle. One, the hypotenuse has the impedance, the base has the resistance, and the perpendicular has XL minus XC or XC minus XL, whatever is the resultant. So all the things are covered. This is the resultant for capacitor and inductor. This is in resistor, and this is for series LCR circuit, their resultant. So if we have XL greater than XC, VL greater than VC case, so we'll be writing it as XL minus XC. Now see, if let's say this is E naught, fine, potentials I'm writing, this is the resistance. No, XL minus XC and all these things are the resistance. R is the resistor, Z impedance is the resistor. Now if I'm writing the voltages that are available, just a second, give me a second. Now impedance that is present, impedance is there. Now if I write it in terms of voltage, so voltage will become E naught for the whole circuit. Remember I wrote it as E is equal to E naught sine omega t. So peak value is E naught. XL minus XC, this will be VL minus VC. R will be having VR. All these will be what? These will be the circuits for it. These will be the values of potentials for it. Fine. Now, if you write and use the Pythagoras theorem, E naught square will be equal to VR square plus VL minus VC whole square, right? This is hypotenuse square is equal to base square plus perpendicular square. That's what I have written. Now, let's write it in terms of impedance now. Let's include the resistors. So, E naught will be equal to what? I naught multiplied by the impedance, I naught into Z. We can write, or let's write it as E naught only. Let's not replace E naught. In the last, we'll replace it. Let's write it as E naught square only. VR, let's write it as I naught multiplied by R whole square plus XL. VL is written as how? VL is written as I naught into XL minus I naught into XC. This much whole square has been written. Now E naught square will be equal to what? I naught square R square plus. This is equal to I naught square X. Let's take I naught square common. So this is XL minus XC whole square. So E naught will be equal to what? Take I naught common. I naught square. What is left? R square plus XL minus XC. This whole square is left till here. Fine, and E naught square. Now from here, if I write the value of I naught square, so I naught square will be equal to E naught square divided by this whole term. This whole term is R square plus XL minus XC whole square. Now, what is the value of I naught from here? This is E naught divided by R square plus XL minus XC whole square. Now see class, from here you can see I is equal to V divided by R using your Ohm's law. So can you notice this? This is the impedance that we have obtained, R square plus XL minus XC whole square. This is the value of impedance that we have obtained. This is the value of impedance. Now, had it been reversed, had XC would have been greater than XL, VC would have been greater than VL, then we would have simply written, this would have come out to be Z is equal to R square plus XC minus XL whole square. Just reverse this. R square is equal to XC minus XL whole square. Sorry, under root will also come over here. This was under root, no? So an under root will also come. This is the formula. And if you see the definition simply says that effective resistance of the series LCR circuit which opposes or impedes the flow of current through it. Simply resistance of the entire circuit, we call it as the impedance. One more thing, if in this triangle, impedance triangle, if you write the value of tan theta, tan phi, let's say this angle is phi, this is the phase difference. So tan phi will be equal to what? XL minus XC divided by R. And in case of the circuit where XC is greater, you will have it as XC minus XL divided by R. Fine. And cos phi will be equal to what? R divided by Z. And here, see, this will also be equal to R divided by Z. So there is no difference in case of cos phi. And cos phi is important. When we'll be doing power, cos phi will again come. This is tan phi's formula. Clear till here? The rest of the things, resonance and all, we'll discuss later. But mainly you have to understand, see what all you have to understand. I'm repeating it once again. This is LCR circuit. The rest of the things we have discussed is same. Two things you have: when your voltage across the inductor can be greater than voltage across capacitor, or capacitor's voltage can be greater than across the inductor's one. So you take the difference depending upon whichever has the greater magnitude. In negative, you won't get the answer, or do not put the modulus. Use the simple formula, whichever is greater, that will come first. So by that, you can have the net impedance. Impedance has to, this is the derivation. Derivation usually, it can be asked to calculate, but rarely for this is asked. Mainly resonance derivation comes in your exam. But it can be asked as it's a part of your syllabus. Now Z is equal to under root R square plus XL minus XC whole square, or Z is equal to under root R square plus XC minus XL whole square. These two things are possible. And if you extend the impedance triangle, these two, tan phi and cos phi, can be written. Cos phi is same, tan phi will again be different depending upon whichever is greater. I have repeated it twice also. I hope it's clear now. If anybody has any queries, you can ask me. Okay, start noting down from here. Done? Now see, XL is equal to XC. VL is equal to VC when your phi is 0, phase difference is 0. So XL is equal to XC, we'll see it again. In that case, you have a purely resistive circuit. You call that circuit as a purely resistive circuit. See, when you have XL greater than XC, then that circuit is ultimately known as inductive circuit. And when XC is greater than XL, you say it's a capacitive circuit. If XL and XC both are equal, then you say it's a resistive circuit. Let's do questions on this. Determine the impedance of a series LCR circuit if the reactance of capacitor and inductor are 250 ohms and okay. So XL is given as 220 ohms, XC is given as 250 ohms, R is given as 40 ohms. Impedance we have to determine. See, XC is clearly greater than XL. Can you notice? So XC minus XL will be used. All right. So Z, which is equal to under root R square, will be now XC minus XL whole square. So Z will be equal to 40 square plus. This becomes 250 minus 220, 30. 30 whole square, so Z is equal to 50 ohms. All right. Note this down. One more numerical we'll do on this. Okay, you can skip this question. This is more of the resonance portion. Resonance portion we'll do right now. See, XC and XL both are equal over here. This condition that we get when XL and XC both are equal, this is known as the resonance condition. XL is equal to XC, this condition is known as resonance. Now, when is your circuit is known to have a condition which is known as a resonance condition? This is when your current is maximum. Now, how current can be maximum? See, Z is equal to what? Z is equal to under root R square plus XL minus XC whole square. See, if I equate XL equal to XC, Z can be written as what? Under root R square plus, I can write it as XL minus XL whole square only, because both are equal. This gets cancelled. Z becomes equal to under root R square and Z is equal to R, that is impedance. So if you can see now what has happened, resistance value has decreased. This net complete value under root R square plus XL minus XC, this complete value was the value of the resistance of this LCR circuit. Yes or no? Impedance was the circuit resistance only. No, for an LCR circuit, we used to say it's the impedance that is present. So if this has reduced, impedance has reduced, then what will happen to the current? It will increase. If you decrease the resistance, if there is no opposition in the flow of current, what will happen to the flow of current? Current will move smoothly and more amount of current will flow now. Why? Because the resistance or the opposition that was coming in the path of the current has now been reduced. So impedance has decreased a lot, so current will be more. Even if you see your Ohm's law, V is equal to IR, I can be written as V by R. If you keep on decreasing the resistance, value of current will keep on increasing. Similarly, here also ERMS, if you write it is IRMS is ERMS by Z. If Z is less, I will be more. Even if you write I naught is equal to E naught by Z, Z will be less, I naught will be more. So in short, impedance is maximum, current is minimum, current is maximum. So this is possible at which condition? If your inductive reactance is equal to capacitive reactance. So a series LCR circuit is said to be in resonance when the current through it has a maximum value. Even in your test and in your exams, if resonance condition is asked, mention this point clearly that current is maximum. In some other batches, I had taken a test on alternating current. Nobody has mentioned this point that current is maximum in case of resonance circuit. They have just simply written the formula XL is equal to XC. See, XL is equal to XC, you have to specify, but firstly mention that current is maximum. Now, why is current maximum? Because XL is equal to XC, that you can mention it. This whole part you have to mention if resonance condition comes for 2 marker. If it's simply a one-liner, 1 marker question, right? LCR circuit is said to be maximum, is said to be in resonance when the current through it has the maximum value. Now see, if XL is equal to XC, values of XL and XC are same. If XL is equal to XC, so how can we write XL? XL is written as omega L and XC is written as 1 by omega C. From here, omega square will be equal to 1 by LC. So omega will be equal to 1 by under root LC. And what is relation between frequency and omega? Omega is equal to 2 pi nu. So frequency is omega by 2 pi. So omega is 1 by under root LC and this 2 pi over here. This is known as the natural frequency or this is known as the resonant frequency. This is known as natural frequency or resonant frequency. Resonant frequency. Easy. This comes a lot to prove this in your exams. This question comes a lot in your exams to prove because it's a very short derivation. See, I'm constantly telling you the longer derivations are usually avoided, but the shorter derivations are maximum asked. Like derivation of drift velocity will be asked to you, that the chances are less for it. But the relation between current and drift velocity, I is equal to NEAVD, that is a smaller derivation. So that has come a lot in your exams. Though anything can be asked, paper is unpredictable, but some things that have been asked in the previous years, that you can see the pattern. So XL is equal to XC, omega L will be equal to 1 by omega C. Omega square will be equal to 1 by LC. From here you get omega is equal to 1 by under root LC. You know relation between omega and frequency, so you can write the value of natural frequency or resonant frequency. Usually a question comes, if it's a theoretical question, then it comes to write this, what is meant by resonance condition of an A series LCR circuit, derive the expression for natural frequency or resonant frequency of the circuit. So everything that I have written till here, you have to mention in your exams. Clear or not? Yes or no? Wafia? Clear? Rufia? Rifat? Reem?
Yes.
Clear? Aman, is it clear to you?
Yes, ma'am. It's clear.
Okay. So note it down, all of you. Wherever you have not understood, let me know. Then we'll complete with this question. Or this is, write it from here. And please mark this as important. From LCR circuit, resonance is a very important topic. Whenever you have your exams, you have your UTs, whenever you're studying, do revise resonance. See, this question says a resistor of 12 ohm, a capacitor of reactance 14 ohm, and a pure inductor of inductance. See, this is not inductive reactance. L is given to you. R is given to you 12 ohm. XL is given, XC is given to you as 14 ohms. But inductive reactance, XL is not given to you. L is given to you as 0.1 Henry. Series and are placed across. So ERMS is 200 volts and frequency is 50 hertz. You have to calculate current in the circuit, phase angle. So for calculation of current, we need impedance, and for impedance, we need XL. XL will be simply given by 2 pi nu L. So 2 into 3.14. Fine, and frequency is 50 into 0.1. So 3.14 into 50 into 2. 50 into 2 will become 100 and 100 into 0.1. So that will become 31.4. Because this will be 100, 110 and 1010. So this much ohms is XL. Now Z will be equal to what? Under root R square plus which is greater? XL is greater, no? So XL minus XC whole square we use. So you have what? 31.4 minus what is this? 14. Okay, so that becomes 17.4. So Z will be equal to 12 under root 12 whole square plus 17.4 whole square. This will be the impedance value. So that will be equal to what? Under root 144 plus 17 into 17, not 17.4 it is. Okay, I'm leaving the answer till here only. You can calculate and see afterwards. Methods, let's discuss. IRMS will be, see, ERMS is given as 200, no? Or 220? 200. See, ERMS is given as 200 divided by Z, which is under root 12 square plus 17.4 whole square. This much amperes will be the current. Second part says what? Second part says phase angle between current and voltage. You can simply calculate tan phi using phase angle. Pi, take pi as 3. Okay, so take pi as 3 is given. See, if we take pi as 3, so here also some simplifications will be done. If you take it as 3, that will become 30. So that will ease our calculations. Let's take it as 30 only. This is 3. So this becomes 30 ohm. So now you subtract 30 and 14, you get 16 whole square. Now this is better. So under root C, 16 into 16 is 256. So you have under root 144 plus 256. So if you add 256 and 144, you will be having 400. So that will give you 20 ohms. See, 200 divided by 20, this will give you 200 by 20. This will give you 10. 10 ampere is the answer for the first part. Now, second part says phase angle. For the second part, phase angle can be calculated by tan phi. See, it will be XL minus XC. That is your, here also it won't be 17. This will be 16. So it will be XL minus XC divided by R, which will be equal to 16 divided by 12. We can simplify it 4 by 3. So phi will be equal to tan inverse 4 by 3. Tan phi, see, tan phi is what? XL minus XC by R. XL minus XC is 30 minus 14 by R. So that will give you this. And if you take inverse trigonometric function, you will be having tan phi. IRMS is given by ERMS by Z. Z is calculated using the simple formula that we have done. So note this question down and text me when you have done. Then I'll stop the class and you all can leave. All those who have completed, you can leave. We'll complete the rest on Thursday now.